So I noticed that that negative there is outside. Anything that's outside the function is vertical. So if we think about this reflection, it is flipping over the x-axis. It is a vertical reflection. So that means I can take some of these points that were on my original graph, those look like key points, flip them, and there will be one point where the blue graph and the red graph intersect. Can you figure out where that point is going to be? Exactly. But sometimes on the final exam, if you're off by a little bit on that point, they might say your shape is off. The x-intercept. Because if you look at an x-intercept, what do you know? You know that that y-coordinate is going to be 0. And if you flip that point, it's going to stay exactly at the same place. Or if you multiply that point by -1, it's going to stay exactly the same place that you were before. And once again, it asks for the domain and range of each one. The domain is everything, and the range is everything, and the same thing on the red. So again, not very hard. A negative just flips it either over the x-axis or over the y-axis. Mathematically, all that's happening is you're multiplying here your y values by -1. But what can make this difficult is if you pick the wrong reflection, you're going to lose all the marks. If you accidentally reflect it over the y-axis, then you do a horizontal reflection. So we think vertical reflection is changing things up and down. That would flip over the x-axis. And questions for practice on this one. You can circle 4, 5, 6, 10, and 11.